Alright guys, so today's key concepts today, you're going to define and identify an ion and an isotope, the atomic structure of an ion and isotopes, and how to figure out the number of protons, neutrons, and electrons for each. So let's go ahead and define what an isotope is. An isotope, we know that elements can have different variations. Elements that have the same atomic number but have different mass numbers are called isotopes. So the key point here is that all isotopes have the same number of protons but differ by the number of neutrons. That's what an isotope is. So here's an example. You have boron 10 and boron 11. You might be wondering what the 10 and 11 mean. Well, those are the mass numbers. So in this case you have two atoms of boron. How do they differ? Well, they differ by one neutron. So find the number of neutrons in an isotope. It's very simple. Well, you take the mass number and you subtract it from the number of protons, just like before, or the mass number minus the atomic number, and that'll give you the number of neutrons. So here are three examples of carbon isotopes. You have carbon 12, carbon 13, carbon 14. All of them are going to have 6 protons, but in this case the number of neutrons changes by 1. So carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and carbon 14 has 8 neutrons. How to write the symbol for an isotope? It's very simple. Carbon 12, you just put a let's go ahead and highlight this real quick. So you put C12 or carbon 12, and C13, which is carbon 13, and C14, which is also carbon 14. So what does this number say? Well, this number tells you the mass number. So it's equivalent to this number here, okay, which is the mass number of the atom. So some isotopes are radioactive, and the reason why radioactivity has to do with an unstable nuclei, and when it's unstable it breaks apart into different particles. So when it breaks apart into different particles, those particles that leave the nucleus give off some radiation, and that's in the form of some kind of energy. Ions are a little different. Ions are charged atoms that either have a plus or minus charge. This happens by either gaining or losing electrons. So remember how isotopes is a change in the number of neutrons. Ions is a change in the number of electrons. Protons, in both cases, both ions and isotopes, stay constant. There's two types of ions. You have an anion, which are negative, and cations, which are positive. So an anion are ions that carry a negative charge, and they carry a negative charge because they have one or more electrons than they do the protons. Cations, and they're usually nonmetals. Cations are particles that carry a positive electrical charge because they have lost electrons, and these are typically metals. So when you do this, basically what you have to do is you have to count the number of electrons. And you simply do that by subtracting the protons minus electrons, and that'll give you the charge of that atom, either plus, minus, or 0. Plus means it's a positive cation, negative means it's a negative anion, and 0 means it's neutral. Here's how they add up. If protons equals electrons, we say it's electrically neutral. If protons are less than electrons, we say it's negative in charge, and if protons are greater than electrons, we say it's positive. So here's a sample problem. How many electrons does sulfur 2-, which is an ion because that has a little symbol up here? This little symbol, let's go ahead and do that real quick. This little symbol here means that it's a -2 charge. So the 2- means it's a 2 negative charge. So how does it add up? Well, We know it's sulfur, so it's going to have an atomic number of 16, which is equal to the number of protons. We need to figure out the number of electrons, and we know the total charge is -2. So what number subtracted from 16 gives you -2? Well, if you do the math, it's 18. So it has 2 more electrons than it does protons, which gives it the negative charge. Remember, protons are always constant, so therefore you do not change that number to make the charge equal. Types of ions formed, as you can see here, here's a trend. Alright, so let's go ahead and do this real quick. This column makes a +1 charge. This column makes a +2 charge. This column over here makes a +3 charge. Make a 3. This we're going to skip. This we're going to skip. This makes a -2 charge. And this one right here makes a -1 charge. Sometimes people put a -3 here, which is true for some compounds, but not true for some of them as well. So we're going to go ahead and put a star there, just so you know that that sometimes can change. But for the most part, it's going to be a -3 charge. Okay? So here's another trend on your periodic table. Go ahead and mark your periodic table so you know where the ions are located on your periodic table. All right, that concludes our lesson today.